Welcome Nikita Orlov. He's from Moscow AI Lab Tech Lead, Picsart. He will give a talk about AI fonts.
Yeah. So, hello everybody. Today's talk will be about one of the 100 projects which we do in company, and exactly that project we did for AI hackathon, internal hackathon in Picsart, and so let's start. What do you know about the fonts? They are everywhere. You can, and this is necessary part for all your photo editing process. You want to create story for Instagram, you need text. You create logo for your business, you need font, and you need to draw some text. And also designers create different content, they create different things, but also they create fonts. So that was one of our core ideas, that it takes a lot of time to create a good and nice looking font. At the same time, licensing a huge library with fonts costs a lot, and there is no machine learning in this area, so we decided that it would be nice if we could speed up the process, simplify life of the designers, and create a huge library for Picsart. So, couple words about the process. First of all, you need to draw a lot of letters, 100 of glyphs for the Latin font, and you have to work a lot on each single character, control the angles, the style. At the same time, drawing good letters is not enough, because when you type the text, you need to check kerning, alignment, you need to support ligatures and other things. What's more, good font has a lot of different styles. Maybe some of you remember in Microsoft Office or anyway you could choose the style bold, italic, and so on. But actually, each of these styles should be, in general, font should have some good idea behind, but all styles like bold, italic, regular, they should be consistent. And also you need to support some exotic things like fractions, maybe some finals and beginnings for the letters. So this is a real tough and exhausting work to create such font. So how we approach this task? First of all, we decided to limit ourselves onto about 100 letters, and we decided to create at first Latin fonts. So numbers, capital letters, some punctuation, all necessary things for you to create a story for Instagram, actually. So how we got the data? We gathered a lot of different characters, found some fonts, and used some interesting images. But at the same time, this dataset is really noisy, and you need to be able to filter it. So we got the text, got the images, but still we needed some filtering, because you can see on these images, some of them are not letters, and you won't be, and it's not funny to use them. So here we didn't try to use hard metric learning approaches or build a rocket. I can say we just trained a simple classifier, found a lot of binary images which can be used like distractors, and just filtered out all the noise images from our data. But for sure you can try a lot of interesting techniques like metric learning and use hard negative mining and predictive loss and all other fancy stuff from deep learning. After filtering, we got quite good data. Unfortunately, some letters were missing, but still we could train the model. So, what kind of framework we decided to build? First of all, we decided to use some generative model. Also, one of the projects in Picsart was transferring raster images to the vector, and we were happy to use it and to apply it. And there are several open source libraries like FontForge, And if you have some SVG data, you can export all your letters and create your own font. Like, there is no any limitations here. But at the same time, we started thinking what kind of generative model we can use. So what we want? We want to pass some noise and to get diverse font library. At the same time, we have tagging for the fonts, we have styles, and we want to vary the properties and get different fonts for our library. So then we need to understand how we represent our images. So there are several approaches. First one is building a collage, when you gather all images of your font into one single image and train generated model to produce that images. It's very comfortable if you want to have high quality and high consistency between your images, because they are on single image, and this is like the best control you can ever get. At the same time, we can use like ordinary tensors, concatenate all images and try to produce them. This requires some engineering, because almost all like default generative frameworks don't support that, but still it's possible. And the last one approach is to treat images independently and to rely on conditioning part of your generative model. So which model we can use? Actually, there are a lot of them, but we decided to use one of the recent works on StyleGun, because this is a good, well-engineered model which can be used for production, and it produces really good results. There are also other like well-promoted, I can say, models. You can try it and play around with it, like VQGun and BigGun, but still we decided to use StyleGun for the and we had behind one of like scientific questions, because almost all the time when you look at the results from StyleGun, look onto these spaces, you see images from one class. But actually, if you look at our task, we want to produce different letters, different styles. And one of the questions for us was, if it's possible to train StyleGun on huge number of labels, number of conditions, and to get good results. Because actually looking at the results, the scores were less, not so good as other models like BigGun could produce. So I really insist on you after this presentation go and study the whole branch of papers like StyleGun, StyleGun V2 and other StyleGun, and the most recent which was published 1 month ago, but still I will briefly talk about what is StyleGun and how it works. So on the left part of the image you can see the default generative model. You get some noise, you use some convolutions, normalization, some sampling, and as a result you get the image itself. StyleGun proposed two core ideas which were transferred to other models also. First of all, you need the distribution of your images when you want to generate is really complex, and generating the whole image just from latent code is not enough. You need to have very complex mapping network which consists of a lot of fully connected layers, and this mapping of normal distribution to the real distribution of your images. What's more, they added noise. This is a really good technique from other papers. It helps model to build more diverse images. And also they added adaptive instance normalization, also well utilized technique, which does linear transformation, and this is conditional GAN actually, but as input it gets latent code. So this paper was really interesting and it changed a lot, but after that authors did really nice homework. They studied all the artifacts which model produced. They started to optimize the model, so it wouldn't take 1 month to get a good model, good results. So they changed a lot of things, they revised architecture and posted white paper for that. So that's I guess all. But that implementation was still on TensorFlow, and not everybody was like able to play around with it, because PyTorch was like too popular at that time. So also, by the way, they tried, like short example, what kind of artifacts they tried to change, to fix, like tooth, and they try to rework the progressive part of the model. You might keep in mind that style gun derived progressive way of training from progressive growing gun. So, and like one of the most, the last question which was to that model, and I have like 100 of images, I have 500 of images. But I'm not able to train this generative model. I cannot get good results. So, and authors of the paper proposed the solution. They proposed to use augmentations, and there is a tricky part. Generative model is still generating real images, not augmented ones. And there were some tricks, but still after that you can really train your style gun having like few images, and it works. So here is like some study on what is going on and on what is happening with metrics when you train model with augmentations. So they also in their paper did a comprehensive study like how it is happening, and and this paper is really can be treated like a guide if you want to train style gun. So let's revise a bit our model and what we have. We have a glyph classifier trained at the beginning. We have 3 types of embeddings: glyph embeddings, tags, style embeddings, again noise, and we have our like upgraded and revised style gun 2 model. And still we are going to produce images, vectorize them, and so on. So this is like, I guess this is a mistaken slide, which should be earlier a bit, with the results of overfitting on the left side. You can see that model is a bit overfitting, and after upgrades it works. So what we have for training? We concatenated our embeddings, we gathered about 2 million of images. We have like compressed embeddings because one hot encoding will expand condition for our generative model too much, so we compress that with PCA modeling, and it takes several days to converge on 2 or 4 GPUs. So, talking about evaluation and how to select the best model, we did one more thing. Almost all the time when models are evaluated on style gun, it is used pre-chain inception distance and kernel inception distance when you extract features from the inception network. But actually during training and choosing the configuration, it was really hard to distinguish between 2 good models to find the best one. So we decided to replace that model. We decided to train own one and gather metrics for it. So this is like on the left image you can see very smooth smooth plot for the inception scores and like oscillating scores for the internal model. So that helped a lot to choose the best generative model from the training process. So a couple words about results. So it actually works. First of all, it produces good working fonts, and if you resolve all alignment issues, you can actually use them, because at the output you get true type font which can be used in any editor, Microsoft Office, Photoshop, Picsart, choose what you want. So, but at the same time, we decided to provide the results to the design team and to ask them to evaluate and say, does it even simplify their work? Maybe we we did something wrong. So first of all, and that was like basic achievement which we were targeting. Some fonts were suggested to use without any editing. Simple fonts can be tuned, and you have to fix some issues, and it takes 2-3 days. And for complex fonts, designers suggest to redraw them and take about 1 month for that process. I was thinking, is it okay to rework the full font and take 1 month for that? And actually, this is even possible result, because we give an inspiration, we give a basic idea to the designer what kind of font we have. Because always, all the time when we order creative content, it's really hard for us to explain what kind of things we want to get. But having this solution, we can really come to the designer and say, I want to do the font similar to this. And we can produce all like requirement documents and describe what we want. And some failures. Of course, they exist. This is generative model. You try to find the trade-off between diversity and between quality of generated images. For sure, we need to work more on consistency of the fonts, alignment between letters, and kerning, and so on and so on. So I think that huge work can be done here. So I guess that's all. Yep. So I'm ready to answer the questions.
Hello, thanks for the presentation. I was curious when we were showing the results, how many fonts did the model generate? I guess a little bit back. Yeah.
This one?
No, previous one.
Okay.
Okay, next one.
Okay.
The other one. Yeah, this one.
Okay.
Just the result.
Okay.
So there were like 4 different ranking of how good the fonts were. Do you remember what were the proportions for all those 4 ones, and how many fonts have your model produced?
Thank you for the question. Quite a good question, actually. We have few designers who worked on that processing. So if I told that there is some significance in proportions, it wouldn't be true. And I can say that, like, from my own experience, from revising, the proportion is like, I guess, 5% of the fonts can be used without any editing, and other ones, well, this is controversial question. What kind of time you need to edit that generated fonts? In terms of how many we can generate, I guess this can be an infinite process. At the beginning, when we did that project for the hackathon, the core idea was like, you come to our website, press the button, and get your own random font. And no one will own that font. And this will be your own one.
Thank you.
Thank you for the very interesting talk. My question is the following. You mentioned that there were 3 ways of generating the output, right? Like, per glyph or per letter, when you are generating the images separately. You also mentioned generating the output as one image and also as a tensor. Could you please elaborate a bit more what you mean by the first and second ways, the tensor one and the collage one and the tensor one, and which one works the best out of the 3?
Yeah. Suppose you are going to come home today and you will git clone style gun and try to train your own one model. So what will happen? if you will be like, I always say that you will be lazy, because all machine learning people are lazy. And for sure you will choose the first one approach. You will concatenate all the images, put them into the folder, and like start training. If you will, but at the same time you will find out that the quality of the results is not good enough, because concatenating all that letters, you cannot train your model on really high resolution, because it will like, and you will get the smaller quality of your letters. At the same time, if you will, after that time, you will revise your approach, study the codes, and you will find out that there is a one flag which can change number of channels, for example. You will rewrite data loading part, and whoa, you can generate tensors, not like one single collage, and it will help you to reduce memory consumption. And train your model on higher scales. So, and the final one approach is like, I can say, it's not the lazy, because you need to train conditional model, not like from generated model from noise. But still, by this approach you can generate 1K size images and get the like best ever quality of that letters. Actually, we tried all of these approaches, and I can say that at some moments you want to train, this is also like trade-off. At some moments you want to train on collage, at some moments you want to train on single images. So, truth somewhere in between.
Okay, thank you. Are there other questions?
Hello, thanks for the interesting presentation. I have two surface questions and one more philosophical. Did you try to transfer the style, as I guess, for handwritten characters, glyphs? And can you show us something special, something exotic characters that you get during your experiments? And philosophical question is, did you think about some other way to generate fonts? Because this topic is very interesting to me, and I was thinking about it. I'm just thinking your opinion. Did you think about something else? Thank you.
Thanks. So, talking about, unfortunately, I cannot say, I can show some exotic examples, unfortunately, but I guess you can reach me in LinkedIn and I will send you a couple of images. This is not an issue. Actually, if you follow the process of the presentation, you can see that all things we did were aimed to reduce the number of exotic images and random ones with our artifacts. We did as much as possible to do it, because this is not enough for production if you get strange letters. So, but at the same time we tried some more thin things, like if it's possible to transfer one font to another, do style transfer. It works, but my opinion here is quite strict. There is no any regularization on that model, on morphing part. For example, when you want to create morphing from one font to another, in Latin space you need to generate certain path. Like you have a normal sphere, you need to generate path, and you don't, during the training of your generative model, you don't regularize it. There is no any process in StyleGAN or any other model. But the models which focus on morphing, they actually do it. They sample some point in between, build the path, and also apply adversarial loss during the training. In terms of how this can be done another way, so my opinion here is that we were, as a machine learning people, we were a bit lazy. We took a vectorization framework from other team, and I think that it's the right time to work on different representations. We are quite strong in terms of generating PNG images, but actually we need to focus on generating SVG. There are some good works, but this is science. This is not like applied research, so we need to invest some time in research. Also, if I advise you to study the history of LaTeX. When people tried computer science to fonts and to typography, they all had all these issues, like the font representation. And if I remember rightly, Donald Knuth created a certain language, coding language, to produce the fonts. Like you start typing, then you run the compiler, and you get the font. So I guess if we go to work on that task, fundamentally we need to revise the whole history, like go back 60 years ago, look what was done, and maybe the solution is not like generative models, it's yet another transformer which produces the code for the compiler. So you are not limited here, you can try a lot of crazy ideas. From the results, one of the best fonts which we get and can use from scratch are the handwritten fonts and calligraphic fonts. Maybe this is a biased dataset in our dataset, but I checked and distribution is uniform. I guess the reason is that our eyes don't see strong artifacts on handwritten fonts, rather than we see them on regular ones.
Okay, thank you very much for the presentation.
Thank you.